Hi, we're going to get started with our proportions unit, and we're going to go ahead and go over some vocabulary that we're going to need throughout this topic. So the first word that we're going to talk about is proportion, and that is an equation stating that two ratios are equal. And remember that ratios can be written as 1 to 1 like this, 1 over 1, or 1 to 1 using the words. We're really going to be seeing it in terms of fractions in this proportions unit though. A ratio is a comparison of two quantities measured in different units. For example, 1 gallon per, or 1 mile per gallon, if you're talking about how far a car can go. Maybe like 25 miles per gallon is more realistic than 1 to 1 in that case, but they're different quantities and they're comparing the two. A scale drawing is a proportional representation of a space or item that is too large or too small to be drawn or built to actual size. So something like a blueprint that an architect might use before creating a large building, or the blueprints for just a house, those are usually a good idea, or something like a map is even a scale drawing. A scale factor goes with scale drawings. It's a ratio that gives a relationship between the distance on the map or drawing to the actual distance or size. So a lot of times you'll see that scale factor as either a sentence or as like a scale of like this distance on the map is equivalent to 100 miles in real life, where it's really just like 1 inch on the map. So that's kind of the scale factors you're going to be seeing on the drawings. So to determine if something is a proportion, we have to find their cross products. If their cross products are equal, then they will be a true proportion. So if you remember from last year, you should learn how to cross multiply. So we take this first product, 3 times 15, and that's got to be set equal to the second cross product, 9 times 5. And when you calculate that out, 3 times 15 gets us 45, and that is equal to 9 times 5, which is also 45. So yes, these two ratios make a proportion because their cross products were both equal to 45. So going ahead and cross multiplying on number 2, 5 times 102 is going to get us 510. We bring our equal sign down and then we multiply 7 times 80. That gets us 560. So since these two cross products are not equal, this is not a true proportion. Moving on to number 3, we take our cross products. 1 times 100 is 100, and 4 times 25 is 100. So yes, these are equal, and it is a true proportion. And moving on to our last one, take your cross products. 8 times 64 needs to be equal to 9 times 72. 8 times 64 gets us 512, and we bring our equal sign down, and 9 times 72 gets us 648. So these two products are not equal. So this is not a proportion. So we're able to use the same method of finding the cross product in order to find a missing value. So you notice in these proportions we have one variable in each of them where one of these values is missing. So we're going to go ahead and cross multiply as we were doing before in order to find the cross products. So that first one is x times 120. Now we can just write that as 120 times x, but that just looks like 120x. Our equal sign comes down, and then we take our second cross product and we say 24 times 75. That's going to get us 1800. So now we have 120x equals 1800. So we're not quite done yet. We need to figure out the missing value x here. So now it's turning into a one-step equation. Right now, x is being multiplied by 120, so in order to get it alone, we need to divide by 120 over here, and anything we do on one side of our equation, we must do on the other, so we're going to divide by 120 on the other side as well. We would divide by 120 on the left side. 120 divided by 120 is 1. 1 times x is just x, so we cross out what we use and we bring down our x. The equal sign comes down, and 1800 divided by 120 is 15. So in this case, x equals 15 would be the missing value for our proportion. Number 2, same idea. We're going to start by cross multiplying. So we say 7 times 108, and that's going to get us 756. Our equal sign comes down, and then we have n times 63. So we can just rewrite that as 63n. That's 63 times n. So right now we're trying to find n. N is being multiplied by 63. So in order to undo that, we need to divide by 63 on both sides. When we do that, we have 756 divided by 63 is 12 over here. Our equal sign comes down, and then 63 divided by 63 is 1. We cross out what we use, and we are left with n. So 12 equals n would make this proportion true. So go ahead and pause the video and try number 3 and 4 on your own. Alright, so hopefully you've tried 3 and 4 on your own. Once you go ahead and cross multiply these, you should end up with the one-step equations 2x equals 72 in number 3, and then 3x equals 18 in number 4. And then once you go ahead and solve these, you're going to get x equals 36 over here in number 3, and then x equals 6 in number 4. So now that we've kind of talked about how we use proportions to solve for missing values, now we can apply this to real-world problems. So in number 1, we have the ratio of teachers to students at a middle school is 2 to 45. There are 900 students at the school. How many teachers are there in the school? So when you approach a problem like this, the first thing you want to look for is, what do we know? So what they're telling us is that for every 2 teachers, because that was the first word that they used, and then they said that was the first number they used, so for every 2 teachers, there are 45 students. So we're going to set up this ratio as 2 teachers to 45 students. And then we're going to set that equal to that other side of our proportion, and the other thing that they told us is that there's 900 students. So I'm going to go ahead and draw my fraction bar here, and I'm not going to put 900 students on top, because on top on our first one was our teachers. So I'm going to put 900 students on the bottom of this second ratio. And the question was asking how many teachers are there in the school. The how many is trying to tell us that's what you need to find. So using what we don't know, we need to use a variable to represent that. So x number of teachers, so I'm going to say x teachers up here. You want the tops of your proportions to be the same type of unit. In this case, we were talking about teachers. And the bottoms need to also be the same kind of unit. So in the bottom here, we had students. So get rid of all those words, rewrite this in just the number form. We have 2 over 45 equals x over 900. And we just need to solve this, so we're going to use our cross multiplication method again. So you take these cross products, 2 times 900, it's going to get us 1800. And then our other side is 45 times x, which is just written as 45x. X is being multiplied by 45, so we're going to divide by 45s on both sides of our equation here. And when we do that, we are going to get 40 equals x. And in this case, we're talking about 40 teachers, so you should put a label on that final answer. 40 teachers is what we mean. Alright. We're going to move on to number 2. Mr. Johnson paid $22.25 for 5 pounds of cheese. How much would 8 pounds of cheese cost? So right away we're going to look for what do we know. We know that there are, you can buy $22 worth of cheese, and that is equivalent to 5 pounds. So on top I'm putting my cost, and on the bottom I'm putting my weight, so that's pounds. So our first one that we knew was 22.25 over 5. That's going to be set equal to, okay, they're asking us how much would 8 pounds of cheese cost. So they told us how many pounds, so we're going to put 8 on the bottom of our second ratio, and then the top of our ratio here needs to be our x, because they're saying how much cheese. So how much would it cost? how much would this cheese cost? So that needs to go with our dollars. So here's our proportion all set up, and now we just need to use our cross multiplication method to go ahead and solve this. So we first multiply 22.25 times 8. That's going to get us 178, and then that's going to equal 5 times x for our other cross multiplication right here. So we have 178 equals 5x. Now we have to divide both sides by 5 because x was being multiplied by 5. And when we do that, we get 35.6 equals x. But since we're talking about a real-world problem, we need to put a label on this and make sense of what that answer is. So we were solving for the cost. So this needs a label of a $sign on it. So we're going to say 35.6, but we need to add that 0 because we're talking about cents. So 35.60 is how much 8 pounds of cheese is going to cost Mr. Johnson. Moving on to number 3 then, it says John was able to drive his car 420 miles on 24 gallons of gasoline. At this rate, how many miles did he drive using 13 gallons of gasoline? So go ahead and try to set up this proportion and then solve it on your own. So your proportion should be set up in a way that we have 420 miles over 24 gallons. That's what we were given. That's what we know. And then they asked us to find how many miles did he drive using 13 gallons of gas. So we should say x is what we don't know, that's miles, it needs to go on top, and we're putting that over the 13 for 13 gallons. Then you just have to go ahead and cross multiply this to get your answer. So we go ahead and we cross multiply, get 5,460 equals 24x. We divide both sides by 24, and that's going to get us 227.5 equals x. Now they were talking about how many miles, so our final answer needs to be written with a label on it, and we're talking about miles, so it's 227.5 miles, and that's how far John would be able to drive just using 13 gallons of his gas. Alright, so go ahead and turn to the next page of your notes. We're going to start talking about scale drawings. How to solve a scale drawing problem. Step 1, you need to set up the proportion. So it's very similar to what we were just doing on the front with our word problems for proportions. You want to set up on the left side the scale factor. That's what is given to you, and we kept saying that that's what we were looking for first. We always put that on the left side. We always need our equal sign. And then on this side, we have to put what do we want to know. So that's where we need to decide, okay, where do I need to put my variable for this? Is it going to go on the top or is it going to go on the bottom? And remember that you need to keep your measurements lined up in your proportions. Once you've set up your proportion, you can cross multiply, and then you're left with that one-step equation. So we have to finish solving that in order to find our missing value. So once again, very similar to what we were just doing. So let's go ahead and look at this example. The scale factor on a map is 2 inches to 3 miles. How many miles are shown by 4 inches? So we set up our proportion. What do we know? They tell us that 2 inches is equivalent to 3 miles. So this is what we know, 2 inches over 3 miles. We put our equal sign, and on the other side, it's what we want to know. So we know there's going to be 4 inches on the map, but we don't know how many miles is that going to represent. So 4 over x. Then our step 2, it says cross multiply. So you need to go ahead and you cross multiply here, get 2x equals 12. That's where we get in step 3 here. 2x equals 12 is our equation that we need to solve. It looks like we need to divide by 2 on both sides in order to get x alone. And when we do that, we get x equals 6 miles. And notice that lovely label right there on the answer in order to tell us what we were looking for. Not 6 chickens, not 6 hot dogs, we have 6 miles right there. So make sure you put your labels on all of these problems. Alright, so we're going to apply these same 3 steps in our next example about measurement. So we have this lovely U.S. customary system converted to metric system map over here. So it's telling us these equivalent measurements. 1 inch is equal to 2.54 centimeters, etc. So in this question it says Paige ran a 5-kilometer race. What would the closest distance she ran in miles? So they tell us that she ran 5 kilometers, but we want to find out how much she ran in miles. They didn't give us a scale factor in the problem. However, over in this nice little chart, there's a scale factor right over here. This ratio says 1 mile equals 1.61 kilometers. Those are the 2 units that we were given in the problem, and we can find their equivalent scale factor right over here. So set up the proportion with the scale factor. So our scale factor, we just found it, is 1 mile over 1.61 kilometers. That's what we know. And then we're asked to find how many miles she ran, so that's going to be our x on the top here because we don't know how many miles she ran. And we know that she ran 5 kilometers, so that's going to go on the bottom. So there's our proportion, we've set it up. Now we need to cross multiply. 1 times 5 is just 5. Put our equal sign, and then we say 1.61 times x, that's just going to get us 1.61x. Cross multiply, so step 2 is done. Now step 3 says solve the equation to find the missing value. So we have 1.61 is being multiplied by x, so we need to undo that by dividing on both sides. So we divide by 1.61 on both sides. 5 divided by 1.61 is about 3.1 equals x over here. But are we done? We need a label, so we're not. We need to say 3.1 miles is what that is equivalent to. So 3.1 miles is our final answer there. Alright, moving on to our next page, we have a bunch of examples for these scale drawings. So if you're feeling really confident about this right now, you can go ahead and pause this video, try those problems on your own, and then kind of scroll through the video in order to check your answers. I'm totally fine with that. If you're still feeling a little bit shaky, stick with me. Let's go through these other examples together. So in number 1, we have a map scale is 1 inch to 15 miles. So that's what we know. The distance from Roanoke to Greensboro is 7 inches on the map. How many miles is it between the two cities? So they gave us our scale factor. It's 1 inch over 15 miles. So we're doing inches over miles over here if you want to remind yourself on what your units should look like. We have 1 over 15 equals, they said 7 inches, so inches need to go on top. And how many miles? How many is what we're looking for, so that's going to be represented with our variable, and our miles are going on the bottom here. First thing we do to solve this is we cross multiply, so we first say 1 times x. Well, that's just 1x, or just x, honestly. We don't even have to put the 1 there. And then 15 times 7 is going to be 105. So we don't even have to divide here because 1 times x, you'd just be dividing by 1 and you'll get 105 anyway. So x equals 105 or 105 miles, because miles is what we are looking for here. Looking at number 2, it says look at the map. Now we have a star on London and a star on Berlin. And then down here it says 2 inches is equivalent to 600 miles. So on this map, 2 inches is representing 600 miles in real life, in the real world. So they're saying if London is 2.27 inches from Berlin, how many miles away is it? So our scale factor, what we know is what's given in that map. So again, let's just do inches over miles. And they tell us that 2 inches is equivalent to 600 miles. So 2 over 600 is the first side of our proportion. And then they told us that London is 2.27 inches from Berlin. And so we put that over x because it says how many miles, and we don't know how many miles that is, so x is our variable. We go ahead and we cross multiply to solve this. 2x equals 600 times 2.27. It's going to get us 1,362. We divide by 2 on both sides to get x alone, and that gets us that x equals 681. And that's going to be 681 miles once we put our label on it. So that's how far away London and Berlin would be according to the scale factor on this map. Alright, so here number 3, it says an architect built a model of a 220-foot tall building he is designing. The model is 25 inches tall and 10 inches wide. How wide is the actual building? So they tell us that it's going to be 220 feet tall. They tell us that the model is 25 inches tall and it's 10 inches wide. And then they're saying how wide is the actual building. So that how wide is going to be in feet because that's what the actual building is going to be. So the way we're going to set up these proportions is tall versus wide measurements. And that's going to help us because we're going to put inches and then we're going to put feet. So how many inches tall is his model? It says it's 25 inches tall. So we're going to put 25 over how tall the building really is, and that's 220. So that's something that we know. That's our scale factor. 25 inches is equivalent to 220 feet. We're going to set that equal to how wide the measurements are, and it tells us that in the model it's 10 inches wide, and they're asking us how wide is the actual building, so that's our variable here, x, and that's going to go with our feet measurement down on the bottom. So there's our proportion. We're going to go ahead and cross multiply this in order to start solving. So 25 times x is just 25x. 220 times 10 is going to equal 2,200. Now x is being multiplied by 25, so we have to divide by 25 on both sides. And when we do that, we cross out what we use and we're left with x equals 88. And that means that this architect's building is actually going to be 88 feet wide. And moving on to number 4, same chart that we saw in our example about Paige running a 5-kilometer race, but now Bill's running a 10-kilometer race, and we're trying to figure out approximately how many miles did he run. So remember, our scale factor was right in that table. I know it's really hard to see here, but 1 mile was equivalent to 1.61 kilometers. So we're going to put miles over kilometers here. And I'm going to say 1 over 1.61 is our scale factor. And then we have, we don't know how many miles he ran, so that's our variable x on top. And we know that he ran 10 kilometers. So we're going to have 1 over 1.61 equals x over 10. There's our proportion. First thing we do is we cross multiply. 1 times 10 is 10. 1.61 times x equals 1.61x. X is being multiplied by 1.61, so we're going to divide by 1.61 on both sides. When we do that, we get 6.2 equals x. So that means that his 10-kilometer race is equivalent to 6.2 miles. In number 5, it says, during a fundraiser at Lunsford Middle School, the school received $20 for every 5 items sold. If the student sold 400 items, how much money did Lunsford receive? So every dollar amount, this $20, we're getting our number of items is 5 items. So we're going to put dollars over items here. And our scale factor, what we know, is $20 for every 5 items, so 20 over 5. And we're going to set that equal to how much money did Lunsford receive. That's what we're looking for. So money needs to be our variable here. X over, says we sold 400 items, so we're going to put x over 400. There's our proportion of money over items. We start by cross multiplying. 20 times 400 gets us 8,000. And that's going to be equal to 5 times x, which is just 5x. And then we are going to divide by 5 on both sides. That's going to get us 1,600 equals x. And this is talking about how much money did Lunsford receive, so we got to put a dollar sign on there. We have $1,600. That's how much money Lunsford's going to make out of this fundraiser. Moving on to number 6, it says at Walmart, 30 erasers cost $3.30. How much would 70 erasers cost? So we know that the number of erasers is equivalent to a certain dollar amount, so we're going to put number over money. So we're going to say 30 erasers, and that cost $3.30, so 30 over 3.3. And that's going to be equal to 70 erasers, and how much did they cost? We don't know, that's our variable, so we put that over x. There's our proportion. We cross multiply. 30 times x is just 30x, and that equals 3.3 times 70. It's going to get us 231. Last step is just to figure out what x is. So since 30 is multiplying x, we're going to divide by 30. When we divide by 30 over here, we have just x left over, and 231 divided by 30 is going to get us 7.7. Our question was asking us how much is this going to cost, so our label needs to be a dollar sign, and it's 7.7, which is $7.70. So we add that 0 on, and there's our final answer. Alright, and now for our last problem, number 7, it says you paid $5 at the gas station for 3 gallons of gas. It's pretty cheap. So it says, how much would 12 gallons of gasoline cost? So we know that the cost per gallon is what we're going to be setting up our proportion as, and we know it's $5 for 3 gallons. That's going to equal, we don't know how much it's going to cost, so that's going to be our variable. The money goes on top. And we know we're buying 12 gallons, so that goes on the bottom of our proportion. So we have 5 over 3 equals x over 12. We have to cross multiply, so 5 times 12 gets us 60. That's going to be equal to 3 times x, which is just 3x. And in order to get x by itself here, we need to divide by 3 on both sides. 60 divided by 3 is 20, so 20 equals x. And here we're dealing with how much would the 12 gallons of gasoline cost, so we're looking for cost, which means we need a dollar sign on here. $20 is how much this would cost us. Now in B it says how much gasoline can you buy for $30. So we're looking for something different. Now we're looking for the number of gallons we can buy. We already know how much money we're spending. So we're going to use our same 5 over 3 to set this up, just as we did in the first one. But now it says we're going to spend $30. Well, our money needs to go on top. So that's going to go on the top of our second ratio. And then it's saying how much gasoline can you buy. So that's the gallons. We don't know what it is. That needs to be x in this case. So we're going to go ahead and cross multiply. 5 times x is 5x, and that needs to equal 3 times 30, which is 90. 5 is multiplying x, so we need to divide by 5 to undo that. When we divide by 5 on both sides, we get x is equal to 18. And they were trying to figure out how much gallons of gasoline we could buy, so it's 18 gallons is our final answer here. Feel free to go ahead back through the video and go to problems that you were unsure of, or pause throughout, whatever. Thank you for watching.